Hello, in this video, I want to talk about how to compute the QIC values for GE models using R. And as we know, GE models are not estimated by maximum likelihood estimation. So AIC is not available for GE models uh, to help us with model selection. Fortunately, there's the quasi-likelihood information criteria, QIC, that's available for GE models. And we know there are several GE packages in R. The two popular ones are geepack and geeM. Okay. And we know there is a QIC function in geepack. And there's another package called MuMIN. It also has a QIC function in that package. It is for computing QIC values for GE models. However, if we say we try to load the 3 library in, you can see it says the following object is masked from package geepack QIC. And this happens when you load in 2 libraries and each has a function with exact the same name. Then the one function will be masked by the first one, and then you cannot really access it. Okay. So I'll show you another way directly. Call the function in the package. So basically, let's detach the library and then set the random seed. Let's create the data set. So this is the data set with the ID, time, and x1, x2, the continuous dependent variable, and the dichotomized binary variable. So first, let's use the geepack to fit the GE model. So you can see this is the way you call gealgebra function in geepack package. So in this way, you don't have to load geepack into RStudio here. You can directly access the geglm function and then fit the model here. And similarly, you can use the geem function in the geem package to fit another model. Okay. And then next, let's use the QIC function in the geepack package. Okay, in this way, then you can print out. It computes 6 numerical values here. And if we want to try the QIC value in the MuMIN package, we can use the same syntax. And then it only computes one QIC value, and the QIC value here is different from the QIC value computed from the geepack. I wonder why. But I'm not going to dig into the details why they differ. But the point is both the geepack and the geM, no, not geM, both the geepack and the MuMIN package has a QIC function that can compute the QIC value for a fitted GE model by using the geepack package. Okay, and we want to try the same. Let's try using the QIC function in geepack to try to compute the QIC value for the GE model fitted by using geM. Also, we use the QIC function in MuMIN to compute the QIC value of the GE model fitted by using geM. And now you can see the if you have a GE model fitted by using the geeM package and you're trying to use the QIC function in geepack, it doesn't work. Okay, it doesn't apply to an object of a class geeM. However, the QIC value of a GE model fitted by using geeM can be computed using the QIC function in the MuMIn package. Okay, so you can see the MuMIn package is pretty general, so you can use it for many different models, including GE models, and it doesn't really care which GE package, R package you use to fit the GE model. Okay. All right. Lastly, I want to print out the GE the QIC value from geepack, and there are 6 numbers here. Let me just go over what they mean. The QIC is quasi-likelihood information criteria. It's used for model selection in GE. A lower QIC indicates a better fitting model with a balance between goodness of fit and complexity. Okay, just remember lower QIC, better model fit. Okay, I'm not going to presenting the math formula here. Okay. And the QICU is the uncorrected QIC. So it is a simplified version of QIC that does not include a correction for the model complexity induced by the correlation structure. So it doesn't really penalize the correlation structure. Okay, so it's used as a benchmark to compare with the QIC value. We'll see next. The quasi-likelihood is the generalization of a likelihood used when the actual distribution of the response is not fully specified, as in GE model. So, and here is the CIC, the correct correlation information criteria. Basically, it's the difference between QIC and a QICU. So it helps determine whether a complex correlation structure is necessary for a given data set. So basically, we want these different to be large, I guess. But I also think maybe we should make this a relative change. So this thing divided by QICU, right? And to see how much change, percentage of change by taking into account of the correlation. Okay. The parameters, this is the number of parameters estimated in the model, including coefficients and any parameters associated with the correlation structure. Okay. And then we have the QICC, called the corrected QIC. And this is really QIC with additional penalty for small sample sizes. This is because the QIC value in small sample size tend to favor, not in small sample, the QIC in general favor more complicated model. But when you have small sample size, you want to make some corrections. And to ensure reliable model comparison in small data sets, where the standard QIC may favor overly complex models. Okay. So basically, what this means, these 6 numbers mean here, just some explanation. But the purpose of this video is really show you how to compute the QIC value for GE models you fit. So I recommend you stick with the QIC function in geepack. Okay, and remember, the lower the QIC, the better the model fit. Thank you.